Hi, I'm Doug Black. I'm editor-in-chief at Inside HPC, and today at Virtual ISC, we're speaking with Brock Taylor. He is Global HPC Solutions Director at AMD. Brock, welcome.
Thanks, Doug.
Since AMD's March introduction of the EPYC 7003 7-nanometer CPUs, we've seen its adoption by many server manufacturers in the HPC industry. Please give us an overview of the EPYC's reception in the marketplace.
It's been fantastic. It is a fantastic part that's built on our Zen architecture that has steadily become a very strong player in the HPC market over the past few years. So when we look at the improvements from our previous generation, we added things like cache enhancement or changes to how we do the compute die that goes onto the chip. So specifically from our Zen 2 architecture, the previous generation, to the current generation, we went from having 4 cores share 16 megabytes of L3 cache to 8 cores that share 32 meg of cache. And when you put that together, it ultimately helps with some of the HPC application needs and the improvements that we've had in just overall performance, how the chiplets are connected, really has been a compelling case that's really helped fuel demand and growth in its application to high performance computing. And the proof is really coming in pretty strong. So today, I think we've surpassed over 200 world records with the Zen 3 architecture and the latest EPYC chip. And that includes records in floating point performance, as well as over 30 HPC application world records. So you're talking about broad applicability that we see not just in high-end data centers, but everyday use in high-performance computing. So we are getting more and more and expect to be a part of what we hope is the world's first exascale-class supercomputing deployment later this year. But as well, we're in everyday use cases from designing better cars, fuel-efficient airplanes, but as well as manufacturing, cost reduction, even movie production. The movie studios are seeing huge uplift in what they can do in visual effects and how many movies they can actually do per year based on what Zen 3 is actually delivering in the latest EPYC architecture.
Yeah, lots of attention around EPYC, certainly. Now, moving over on the GPU side, update us on Instinct, if you would, and highlight some of its key attributes and why you think it's a good choice for the HPC community.
First off, our latest Instinct line has actually crossed the goal line of 10 teraflops in FP64 performance, right? So again, you're seeing a lot of fine tuning towards high performance computing that ultimately gets rooted in taking our general architecture for GPU and then splitting it into more focused areas. So we have basically the compute side and the graphics side. And when you can take that architecture and then allow it to have one focus that focuses on the graphics and one side that focuses on the compute power, we're able to take out the things that we don't need for high performance computing or acceleration of HPC applications and really target that architecture, what is in our Instinct line for the data center, at providing just the compute power. And that gives you more of that power and performance attributes that are needed in the data center and help accelerate some of the common applications. And so we're continuing to work on how to get those applications ported over to use our ROCm stack, which is what takes best advantage of that architecture, but provide the developers the ability to use open source standards and coding mechanisms so they're not locked into any architecture. And that really helps fuel the growth and transfer of codes over from CPU to really efficient GPU land. And when you pair those two together and add AMD's Infinity Fabric, we're also providing that data highway that helps move data between CPU and GPU, as well as GPU to GPU, and really capture a lot of performance that helps fuel demand.
So what other initiatives might we expect from AMD in HPC over the next 12 to 18 months?
Well, one of those is along the lines of helping researchers and helping code developers port their codes to GPU or take advantage of this hardware acceleration. So we've just launched an AMD initiative aimed at educators and researchers to make sure that they're getting the tools they need and the information they need to start moving those codes and porting those codes in a way that they're going to capture that value, but also keep that value as they move forward and maintain those codes. That's literally called IAER. You can go to amd.com/IAER and find information. And then that will help point you to the resources that AMD provides to help make it easier for developers to move to use the Instinct line in their coding.
Okay, so now looking at exascale, AMD, of course, is heavily involved in two of the first U.S. exascale systems, including Frontier, scheduled for installation later this year at Oak Ridge. Please give us an update on your work with your technology partners and the national labs in the exascale area.
Yeah, so it's obviously it's very complex to deliver that type of machine in a world-class leadership machine. Definitely involves the pairing of CPU and GPU and the Infinity Fabric as well between them. As I mentioned, moving data around and really being able to respond to whatever the workload need is for that particular use case, right? So it involves a lot of AMD software as well. So as we're delivering the drivers and the performance libraries that the developers of the codes that will run on these machines need to achieve the scalability and the raw performance of scaling out across that many nodes takes a lot of effort and collaboration between our side, the systems vendors, and the developers themselves to actually attain the performance that we're going to get out of that system. So it is a long journey and one that continues as well after deployment that will continue on. But the investments that we're able to make in getting to exascale and getting to that system actually allow us to take that investment and propagate it across not just that system, but all of HPC. And so we look at those elements of what we deliver and what we're doing in exascale and continue to fuel future generations as well. So again, the pairing of CPU and GPU and how they're going to share memory, I think we're already looking at how that innovation comes in pairing with basically shared memory and more coherent memory between CPU and GPU.
Okay, an interesting range of challenges there. So
Absolutely.
Now looking at ISC, what will be your focus at this year's conference? What are some of the major activities you'll be involved in?
Yeah, well, as you said, it's virtual, so you can stop by our virtual booth and you'll be able to learn more about the latest EPYC and the latest Instinct products, as well as some of the initiatives we're doing around exascale in the future. You can expect to see and learn more information about the different things that we're doing with these national centers of excellence around the globe, as well as some of the codes that we've optimized and some announcements around the tools and different developer products that we're providing to make it easier to take best advantage of AMD architecture. And that includes the academic educator and research initiative that I mentioned earlier. So you'll be able to learn more information about how to get those resources and that tooling that developers need to best take advantage.
All right. Well, Brock, it was great to spend some time with you, and I wish you all the best success at ISC.
Thank you. Excellent. It was great to talk to you.
Thanks.